So let's work on 9-3 transformations of quadratic function. The transformations could be of different types. The one kind of transformation is translation. That means the graph of quadratic function can move either up or down, or left or right. That kind of transformation. The other kind of transformations that you will see in quadratic function is reflections. And mostly we deal with reflections across the x-axis. We won't have rotation in quadratic functions. And the last one is dilations. That means the graph will be either narrower or wider. I also want to tell you that the standard form of quadratic functions is, once again, fx equals to ax squared plus bx plus c, where a cannot be 0. And the vertex form, which is the another form of quadratic functions, which is used to show the transformation of quadratic functions, is fx equals to a x minus h quantity squared plus k, where h and k represents the vertex. Now, the vertex form, the different parts of it will show the different kinds of transformation. For example, this k, if it is positive, the graph is going to move up. The graph of quadratic function moves up. And if k is negative or less than 0, the graph moves down. This h, if it is a positive value, that means it is, for example, x minus 2 quantity squared. If it is like this, then the graph is going to go right. So h is basically 2, or h is greater than 0, the graph moves right. And if there is a plus sign here, for example, if we have something like x plus 3 quantity squared, then this graph is actually going to move to the left by 3 units. And this value of a also gives us two kinds of transformations. One is if a is a negative quantity, then the graph is going to reflect across the x-axis. And also, if this value of a, the absolute value of a, if it is greater than 1, then the graph becomes narrower. That's kind of a dilation. The graph becomes narrower. And if the absolute value is between 0 and 1, then graph becomes wider. Let me show you with an example. Let's say if fx is 2x minus 4 quantity squared plus 1. This graph, compared to the parent function, which is y equals to x squared. As you know, the graph of a parent function, y equals to x squared, looks like this. Then compared to the parent function, this graph will shift 4 units to the right. That means this is going to slide 4 units to the right, 1 unit up, and also this will become narrower will be compressed vertically. And it will also shift 4 units right and 1 unit up. So compared to this parent function, this graph is going to be 4 units right, 1 unit up, and it's going to become narrow. Something like this. It's going to become something like this. So the graph is going to get narrower. Let me show you a few more examples on this topic. So here are the 3 examples on transformations of quadratic function. So the question is, describe how the graph of each function is related to the parent quadratic function fx equals to x squared. So can you tell what kind of transformation is this one? You can compare this function to the vertex form of the quadratic functions. If you compare this to the vertex form, you can see that a is basically 1 here. There is nothing next to x, that means h is 0 and k is 3. So this graph is just going to move up by 3 units. So if this is the graph of the parent function, y equals to x squared, then the graph of hx, which is x squared plus 3, will simply move 3 units up. That's it. So you don't have to do much except show that this graph is going to translate 3 units up. The next function, compared to the parent function, this graph is going to move 2 units to the right. If there's a minus here, it actually moves the function 2 units to the right. So this is the graph of the function. The third one, this one, since this value of a, the absolute value of a is between 0 and 1, this graph is going to compress vertically. That means it's going to become wider. So this graph is going to become wider than the parent function. Thanks for watching.